Hello and welcome to Statistics for Business 1. I'm Shankar, your instructor for the course, and this here is Lisa, my unconditional friend.
But at times, we're mutually exclusive.
Probably. We've downloaded a data set from the UC Irvine repository and are busy discovering probabilistic truths of individuals in this census data set making over or under $50,000.
Never thought it would be so easy.
You just meant the probability bit, right? In this segment, we are going to place some conditions on our events and then see how the raw probabilities get changed by the condition. Along the way, we shall define what conditional probability means. We had drawn up a pair of confusing questions some time back, remember? Here they are. You might have guessed that I'm going to build a pivot table. I'll do that and try playing with the occupation variable. Now, in this pivot table builder, I'm going to scroll down to the occupation variable and put it down in my row labels so I have all of the occupations over here.
Why is that?
Because I might want to examine the data for another line of work, not just managerial. We are now ready to tackle the first question. Given that a person in our dataset is a managerial executive, what is the probability that he or she makes over 50K? So for that, I'm going to restrict these row labels to exactly exec managerial, and aha, I have this final pivot table. The sample space is clearly all managerial executives and there are 3,991 of them. That's our denominator. The event is that of a person making over 50K. That's our numerator, and we've got 1936 of these.
Let me think. The probability is 1936 by 3991, which is about 48.5%.
Awesome! Now, what if we were looking at salespeople instead? I bet you can crack this one. What's our other question, Lisa?
Given that a person makes over $50,000, what is the probability that he or she is a managerial executive?
Now, our sample space is everyone who makes over 50K. But I don't need to build another pivot table. I'll just expand the row labels like I've done here to include all of the categories. Now the probability is easy to build from the column for greater than 50K, which I just pointed out. It's simply 1936 over 7507, which is about 26%. Now contrast this with 48.5% for the other way around. What we did was to contrast 1936 with 3991. Remember that?
The denominator went from nearly 4,000 to 7,500.
Yes, that's the number of people making over $50,000. We calculated these probabilities systematically, but some of us could use a Venn diagram. We have drawn one approximately to scale to see what is going on. Let M be the set of exec managerial people in our data set and O the over 50K people. The overlap M intersection O has a size of, you guessed it, 1936. The overlap is about half the size of M, technically 48.5%, whereas it is about a quarter of the size of O, technically 26%.
Now I see the switch.
We are now in a position to state an important definition. The conditional probability of an event A, given that an event B has occurred, is written as P of A given B and is equal to P of A intersection B over P of B. The event B here is a condition that we have specified. So Lisa, what is P of B given A?
I wasn't listening. Is it 1 over probability of A and B?
Tempting, but the reciprocal can exceed 1, it's not a probability. Try again.
Sorry, is it 1 minus the probability of A given B?
Wrong. That looks like guesswork, Lisa. By our definition, P of A given B is P of A intersection B over P of A, and it has no easy relationship with P of B given A. Let's focus on people who make under $50,000. Then we can ask if the gender divide is similar across the races. I've gone ahead and built the necessary pivot table with the focus on the race variable. I've put it here in my race tab. Now these numbers are all quite confusing. So we've replaced everything by their column-wise ratios. For example, 96 has been replaced by 96 divided by 252 and so on. These give us probabilities broken down by race. The gender divide has a surprisingly similar pattern of a 40-60 split between females to males across most of the races.
Except for the blacks, where women rule, yeah.
Who would have guessed? The numbers tell us the real story. Now I'll let you figure out the story when the salary level of everyone exceeds $50,000. Let's answer the remaining question. Is it more likely that a white female makes over $50,000 compared to females from all other races? I'll just go ahead and flip this over to greater than 50K, and you notice that all of these have been recomputed. The ratios have changed. I caution you not to generalize any conclusions from this data set to the population at large. Truth be told, whereas only a third of this data set concerns females, the US workforce is divided almost equally between the sexes. For us to be able to make such generalizations, we must ensure proper representation, which is beyond the realm of our discussion here. We have worked with conditional probabilities in this segment. When we declared that there was no simple relationship between P of A given B and P of B given A, we didn't say there was none. Indeed, there is one, and it's a much applied result in the field of statistics, and it's known as Bayes' rule. Now, conditional probabilities form the backbone for Bayes' rule, which we're going to talk about in our next segment.
We'll see you under the condition that you go through our exercises.
I will too.